This is the vocabulary for topic 7. So the first word is circle, the set of all points in a plane that are equidistant from a fixed point called the center. And it says a circle is named by its center. So we would call this circle, circle O. Let's just talk about the definition for a second. So it says the set of all points that are equidistant from the center. So here's the center of the circle, and every point, like let's say this one and this one, they're both the same distance away from the center. So if you draw a line from that point to the center, whatever that distance is, it's the radius, it's going to be the same distance for this other point. This is also a radius. So all of these points around the edge have that characteristic, that they're all the same distance away from the center of the circle. So these are all radiuses. Okay, and it's very important to realize that the definition says the set of all points in a plane. Okay, meaning that they're limiting the discussion to two-dimensional, like a flat piece of paper. Because if you don't do that, then that leaves it open to interpret it as even in 3 dimensions, which would actually be a sphere. So in case you ever get a question about a definition about a circle, it definitely matters that you say that it's on the plane. Okay. All right, so a radius is a segment whose endpoints are the center of a circle and a point on the circle. The distance from the center of a circle to any point on the circle. Okay, so the radius, it goes from the center of the circle out to the edge. And all radiuses are the same length, which is what that note says at the bottom. Okay, next. A chord is a segment whose endpoints lie on the circle. So you can see CD there. It's the endpoints of that segment. They lie on the circle. So that's a chord. So they're showing 2 separate chords there. They can be really small. They can be kind of long. These 2 look like they're the same size, but you can imagine drawing another chord that's doesn't take up so much length, that it would be smaller. So for example, this is also a chord from here to here. Okay. Next. A diameter, notice that it says it's a chord. A diameter is a chord that passes through the center of the circle. So, although it's called a diameter, it is still also a chord, because the definition of chord was that it just, its 2 endpoints were on the circle, and a diameter has the same property. It just also goes through the center of the circle. Okay, concentric circles are circles with a common center and different length radii. Okay, so you can see the 2 circles that they're identifying there with R1 and R2. R1 is longer. R1 is, that's associated with the larger circle around the outside. And then the smaller radius there is for the smaller circle. And then the region between that 2-dimensional region, it looks like a ring, that's called an annulus. Okay, congruent circles. Circles are congruent if they have the same length radius. So that is a pretty short definition of congruent circles. I don't know if you want to remember what the definition of congruent triangles was. That was a lot more complicated. You needed all 3 sides to be congruent and all 3 angles. It was like a lot of things that you had to check to see if 2 triangles were congruent. With circles, all they have to do is have the same radius. Okay, going. An arc, an unbroken part of a circle consisting of 2 points on the circle called the endpoints, and all the points of the circle between them. Okay, so an arc is basically like a portion of the circle. Remember that a circle doesn't include the center. The center is not included in a circle. The circle technically is just all of the points along the outside. Those are the circle. Anyway, so what an arc is is it's just a portion of the circle. So like for this portion of points from here to here, that would be an arc. And you would name it arc AC. And you give it this symbol. So it's kind of like line segment. Line segment is like this. That's how you designate an arc. Okay, next. Okay, a semicircle. It says it's an arc, but it's just that the endpoints are the endpoints of a diameter of a circle. So you can see here, it's basically an arc. It's just that it's long enough. It's just the right length so that its endpoints are the same endpoints as some diameter. Okay, so that's called a semicircle. There's actually two semicircles drawn here. There's one up here, and there's another one here. Okay. Okay, so a minor arc and a major arc. A minor arc is an arc of a circle whose endpoints are on or in the interior of a central angle. Well, that's kind of funny because we haven't defined what a central angle is. We'll define that a little bit later. But we'll do this one anyways. So it says an arc of a circle whose points are on or in the interior of a central angle. Okay. Well, honestly, I find that definition kind of complicated. But I think the easiest way is basically an arc that's either less than 180 degrees, which is actually saying here. So it's saying what I would think would be the easier way to say it. It's showing it in the diagram, but it's not saying it in the definition. So a minor arc is just an arc that's less than a semicircle, smaller than a semicircle. And then a major arc is one who's larger than halfway around the circle, larger than a semicircle. Okay, next. Oh, so here they talk about central angle. So a central angle of a circle is an angle whose vertex is the center of the circle. So notice where the vertex of this angle is. It's right there at the center. Okay, and one of the things we're going to learn is that however many degrees this is, let's say this is 60 degrees, then we're going to measure this arc out here, BC, is going to be 60 degrees as well. So we're going to define an arc measure in terms of a central angle. And it'll just be a one-to-one correspondence. So they'll just be the same number. Okay, let's keep going. Central angle and intercepted arc. Oh, well, I guess this is what I was just saying. So this the degree measure of this arc, BC, is the same as this degree measure right here. It's just that this is measured around the edge of the circle. This is actually part of a circle, whereas the angle, as we've dealt with them throughout the class, never really had anything to do with a circle. Okay. Next, inscribed angle. So it's another angle inside a circle, but it's not a central angle. So remember, the central angle had its vertex at the center and went out to the circle, to the edge of the circle. This is an inscribed angle. Its vertex is actually on the circle, and then its two sides intersect the circle over there at A and B. Okay, so this is called an inscribed angle, and there's a very important theorem regarding inscribed angles. You can see it down there, but we're not going to talk about it yet. For now, we just want to know what it is, an inscribed angle. It's an angle whose vertex is on the circle, as opposed to at the center of the circle, like a central angle. Okay. Inscribed angle theorem, we're not going to talk about that. I'm not going to talk about this yet. Inscribed angles, nope. Arc length. No, not yet. Sector, no. Tangent. Okay. So a tangent is a line that intersects a circle in exactly one point. All right, so you can see this line, that blue line intersects in one point, as opposed to like a chord, which would touch the circle at 2 places. Okay, and we're going to learn properties of tangent lines, namely this one, but we're not going to talk about that here. Circumscribed angle theorem, nope, no theorems for this vocabulary. None of this. Okay, that's it. So just the ones that I stopped and actually read the definition for, those are the only ones you guys are responsible for. Yeah, well, I didn't read this one all the way. Let me go ahead and read this one. A line that intersects a circle in exactly one point. The point where the line intersects the circle is called a point of tangency. Yeah. Okay, so you got tangent. Tangent, none of these. None of these, none of that. So from here, inscribed angle, and then any other one that I read above that. Those are the ones you're responsible for. All right, I'll put how many exactly there was in the homework posting.